So, very welcome everyone. How are you doing? Doing good? Remember last week we were stopped at the discussion about, not last week, last session. I keep saying last week. So last session we will stop at the discussion about the battery. I'm gonna just pick up from where we left. I finished it where I was introducing different type of battery, and I stopped at nickel metal hydride, as you can see on my screen. Today I'm gonna start introducing a structure of lithium-ion battery, different layers inside it, application, and of course for lithium-ion battery, we have different materials in order to develop such batteries, and they are the most important type of battery, which is very common for electric vehicle and hybrid electric vehicle applications. So stay with me, since this discussion is very, I would say, useful for anyone who's interested in energy management system, more specifically battery design for electric vehicle and hybrid electric vehicle application. When you know what's the difference between different type of lithium ions, many people, they do think when we talk about lithium ion batteries, we have only one type of lithium ion battery, but I would say we have generally one battery type to become constructed from lithium ion, but the material used in electrode and cathode, and of course as electrolyte inside the same battery group or battery family, could be different material. And that's exactly the most important part, which is defining what's the difference between the lithium ion batteries and why we are using different type of them. What makes them specific for electric vehicle or hybrid electric vehicle application, or maybe for other applications such as your handy devices, such as cell phones, such as, I would say, laptop, or any other electronic devices. So this is where we have left the discussion. We already learned in any battery here. We finished it right in here. And we already learned most of the batteries out there, they do have 3 layers: positive, negative, electrolyte, and of course, you need to learn about the separator. Although both electrolyte and separator, both of them are responsible for flow of ion, but still there is a huge difference between these 2 layers, right? So let me just summarize it for you. I'm gonna quickly also show you a video right after this summary, and I'm gonna show you how this layer can sit beside each other in order to form a battery. So far, we've learned that any battery has positive, negative, and of course in here, in the previous slides and session, I said that we have electrolyte or separator. I would say, when I say electrolyte or separator, we always have both of them, right? For example, in here, we have like the electrolyte to be liquid. This is like in this battery, we have, what is it? This one, we have positive electrode, and then we have negative electrode. This is lithium cobalt. For the positive is lithium cobalt, and negative is carbon. But still, we do have separator and electrolyte. So electrolyte, in fact, is in charge of moving like the ion, anything in here, which is just covering all around the positive and negative electrode, and sometimes just maybe like in here, and most of the time is either solid or liquid or gel. I introduced different type of the electrolyte in last session. So this is what it is, in charge of ion movement, because either you're looking at the charge process or you're looking at the discharge process. In discharge, ion supposed to move from negative to positive, and it has to move through the electrolyte. Do not confuse the application of electrolyte and separator. How about separator? In fact, separator is a physical layer, right? And the main, I would say, job for the separator is avoiding any type of accident between the electrodes. Because if we are removing the separator from the battery, the positive and negative electrode, they will touch each other and it will cause short. Therefore, we need to prevent electrodes from touching. Electrode in here, electrode from positive electrode, negative electrode. Therefore, separator, in fact, is preventing any accident or touching between the two electrodes. But electrolyte is in charge of main reason for electrolyte is just being able to move ions from positive to negative if it is charged and negative to positive if it is discharged. And without that, the ion movement is going to be difficult. So, in fact, as I said, electrolyte could be either liquid, gel, or solid. But separator, I'm going to say, for example, if I have one layer in here called separator, this is going to be a membrane. It's a physical, very, very thin layer that could be created from different material. Well, this one, it will block the electron. I'm going to write it. This one blocks the electrons. But this one is moving the ion. In fact, this one also allows the ion movement. But the main job is blocking the electrons, the positive and negative electrons, to avoid short circuit. In fact, if you are having a battery which is in trouble, if the trouble is separator, I would say that will be considered a safety hazard, because not having a proper separator between the two electrodes simply means you are going to have a short circuit. And short circuit means fire or the possibility of explosion of the battery. Therefore, this is super important for the safety of the battery. But if you are having some concern about the electrolyte, it simply means you do not have any movement of ion between the charge and discharge process, and that's when we call the battery is dead, right? Of course, this is known for you when your battery doesn't have a charge, you may call it the battery is dead. But if the battery is broken and it's not accepting charge, or let's say it cannot maintain the charge, you are just hooking it up, your cell phone even, but it won't maintain the charge. As soon as you disconnect it from the outlet, you can see a still also in there, it was showing maybe 95% to 100% charge, but you disconnect it within few seconds or maybe at least a minute or two, you are going to see that still the cell phone is going to turn off. That simply means your electrolyte is damaged. It's not able to move the ion anymore. Therefore, the battery is dead, right? And that's something which is not fixable. So please make sure you have a good understanding of what is separator and what is electrolyte in battery construction. So now, before I move to that video and show you a little bit more detail about those porous electrodes, I said that your negative and positive are going to be porous because they have to be able to observe the ion in order to be charged or discharged. Therefore, they have to have a construction which is like porous construction. I'm going to show it in a video. But before that, generally why we are going to choose lithium-ion batteries over any other type of battery for electric or hybrid electric vehicle application. The reason behind it, the main reason is lithium-ion battery has high specific energy. Remember, for the previous type, for example, right in here, for the nickel metal hydride, I said they can have almost like only up to 1.2 volt per cell. Therefore, if I'm going to use them for vehicle application, I have to have so many of them, which is causing you to have a huge battery pack, right? Therefore, these are not the best option for electric vehicle, but still we can use them for hybrid electric vehicle. Why is that? Because when we use them for hybrid electric vehicle, they are going to be a secondary source of energy. Still, we do have combustion engine in hybrid electric vehicle. So the main source is not going to be the battery. these are temporary source or maybe secondary source for the energy inside the hybrid electric vehicle. Therefore, still we can have them. But when it comes to electric vehicle, lithium ion is the best type, because look at here, see, it's almost 3 times. So it's really a specific energy is higher than that. The voltage, providing the voltage is really higher than that. That one was almost 1.2, but this is 3.6. Different type, regardless of what's the material for the positive and negative. Still, lithium-ion batteries, they have the potential to be fast discharge or fast charge without less, I would say, trouble. Also, lithium-ion battery, also they do have the concern to like go through the explosion because of the very sensitive to high temperature, and they can cause, for example, fire because of like a speed of chemical reaction inside the battery. But still, they do have high specific energy, and then at high temperature, they can still have a great performance if we are considering all the conditions. And definitely, this is super important. If they are sitting on the side and you are not using them for a while, the range of or the rate of self-discharge in lithium-ion batteries is lower than other batteries. While, for example, for here, I said it, for nickel metal hydride, if you just keep them like on the side, they go self-discharge, their rate of self-discharge is high, therefore it is not efficient to be used for electric vehicle application. So let me show you quickly this video, which is a little bit more detail about the construction of the battery, how the layers are connected, and what is the exact requirement in order to have the batteries to be fully functional. Look at here. If any of these layers inside the battery is removed, that battery is dead. Therefore, for lithium-ion batteries, we always need the porous separator. We need the liquid electrolyte, and definitely, in this case, this is a silicon on anode, right? So these are the main structure, and they have to be always here. In the next part of this video, you can see if they are separated from each other. Look at here. For a structure of lithium-ion battery, we can have many layers of these separators. For example, this is only one single cell. Beside this, we can add again electrode, again separator, again like another electrode, which might be positive. So this is super important to have this understanding of the construction of the battery. And exactly this is the part that you can just reshape it. You can create cylindrical battery out of this layer. You can create prismatic battery. You can create pouch battery. These are the different type or shape of the battery, which in upcoming slide I'm going to show you. So this is, for example, solid state, and the other one, lithium ion. And this video is from BMW. So I'm going to go back to the lecture slide. Any questions so far about different layers of the battery and the structure? Anything? Besides the advantages that I already mentioned them, let me also talk about the disadvantage. The most maybe disadvantage about the lithium-ion batteries is the cost. Lithium-ion batteries are rechargeable. Definitely, they are reusable. If you are paying some money for some time, sometimes they say, for example, 5 years, sometimes it is 3 years. Maybe you can look at the life cycle. The life cycle is mentioned maybe 5,000, 3,000, 7,000. It depends. They do have different life cycle, and that's something provided by the manufacturer. But they are expensive in case you have to replace them for electric vehicle or hybrid electric vehicle. They are expensive. Looking at this, you can see either like, for example, for hybrid electric vehicle, they are placing them on the chassis, and then they put like the cabin on top of it. So the shape of them is super important. Not every lithium-ion battery could be reshaped and fit in any different car, but we do have some type. I'm gonna introduce it shortly. Those are not very common, those are not efficient, but we do have a type of lithium-ion batteries that one of their layer is just air, is oxygen. Therefore, that one, it can be reshaped to any other shape for different application and for different vehicles. So in here, you can see also, in case we are going to design a battery pack using lithium-ion battery, so definitely we have to consider thermal management. Why is that? Because as I said, lithium-ion batteries, they do have sensitivity to temperature, right? Therefore, if we do not have like coolant system, if we do not have coolant system, we are not gonna be able to maintain the safety of the batteries. So that's super important. And most of the time, adding a coolant system is gonna cost a lot for the manufacturer. Therefore, the total cost of the vehicle may be impacted based on that. So that's another thing that we have to consider. And of course, in addition to that, I said it before, I'm gonna bring it up again, battery management system, which is a unit, which is like a control unit in order to be able to report or maintain the state of health, a state of charge, a state of discharge, and all different characteristics of the battery under a certain monitor, or maybe I would say LCD sometime. Sometime it will be sent to the dash if it is hooked inside the vehicle. Therefore, that also by itself, it is a mandatory part for lithium-ion batteries to be able to keep them safe in case either high temperature is impacting them or maybe high voltage is there. It can disconnect the battery and it can avoid explosion for the vehicle. So that's another thing which is causing actually cost for the battery. Another important type of the battery, but not very well known, is going to be zinc air battery. I just said it. We have one type of the batteries that still they do have the three main layer as positive, negative, and electrolyte. But the difference between this one and any other type of the battery is in this one, we have one layer to be air. Therefore, although this is giving the potential to keep it a little bit more like cheaper, because one layer is missing in here. In fact, is air. We are not going to pay for it. So it becomes cheaper. It is more efficient in terms of cost. But there is another factor in here. Zinc air batteries by default are considered primary, not secondary. Although in here you can see they are rechargeable, but they are not rechargeable through just electricity. They are rechargeable mechanically. Simply means since this one layer is air, another layer, which is the anode or negative, is zinc. After each use, you have to change the zinc layer. So it is in fact rechangeable than rechargeable. So still air is air. You don't have to, if the battery is used only one time, you have to take the zinc layer or the anode out and replace it and still use the battery. So that's why in some cases it might be under the category of the secondary or rechargeable batteries, but in fact is a primary battery. So it has some advantages than other primary batteries, because other primary battery you cannot fix them or you cannot troubleshoot them. If they are damaged, they are damaged. But in here, if the anode is used, you change it, you use another zinc plate in here and still you can use it. But there is a great advantage in here. Since one layer is air, this type of the battery, they do have the potential to be reshaped. You can create them in any shape for any application. But most of the time, it has to be like a thick, or I would say heavy battery, simply because one layer is air and you need enough of air. Therefore, this is going to be a thick battery. I would say the advantages is, since They can be like created in a huge size. They do have a potential of having like 600 kilometer to 3,000 kilometer for driving. And of course, they do have like a specific energy to be really high. And another thing is easy troubleshooting since you can replace them. But nowadays, researchers are really focused on switching it to really rechargeable battery, and they did it. It is now doable to create the rechargeable type of the zinc batteries, but the disadvantage of those rechargeable type of zinc battery is in order to do so, you need a huge infrastructure, which makes it costly, which is not efficient. It is doable, but not efficient. But when you have it, after like going through all of the complicated process to have the rechargeable version of this type of battery, they are really efficient because they can have high specific energy, and you can use them for even electric vehicle in order to drive up to 3,000 kilometers. Therefore, it is a great choice for researchers to work on it, to be able to bring it to a stage that creating such a battery is easier, and gradually you can see them probably at some point common for different applications such as electric vehicle application. I already said what is the disadvantage. Disadvantage is they are bulky because they have to be huge, and of course they have limited life cycle because after each use the zinc layer is garbage and you have to replace them. So now, just having all of those discussion, it's time to learn a little bit about another type of lithium-ion batteries. I would say lithium polymer. Li poly, lithium polymer, and usually if you want this is going to be LiP, they call it sometimes just LiP. If you want LiP, it has to, or LiPo, both of them, or Li poly. Both of these three means lithium polymer. In fact, they do have a solid state electrolyte. What does it mean? Remember I said electrolyte in lithium-ion batteries, it could be solid, it could be gel, it could be liquid. In polymer type, electrolyte is solid state. It simply means it's a jelly material. It's a jelly material. That's why we say it's a little bit more close to solid state. These lithium polymers are most of the time pouch type. Before explaining more, let me quickly show you what is the difference between them. When I say pouch type, look at here. These are the three different shape of batteries. This is cylindrical, this is prismatic, and this is pouch. Also, pouch and prismatic, for just some people may not be easy to recognize which one is pouch, which one is prismatic, but I'm gonna explain the difference. Pouch type batteries are thinner batteries, and most of the time the layers inside the battery are not folded. They are single layers stacked on top of each other and compressed, right? That's the difference between the pouch and prismatic. But prismatic batteries, they are single layer. For example, a very long single layer of cathode or anode or separator, and they are folding it to too many like layers. It is common, both of them. It is common in like electronic device, like small electronic devices, such as again laptop, maybe some toys for the kid, or maybe even cell phone. This one, if maybe one layer is damaged, of course the entire battery is damaged, and you have to garbage it. So since it is like just single layer, it is folded too many times. But after it is folded too many times, that doesn't mean it's a single cell, because after each fold on top of it, they install electronic circuit, means all of the positives are going to be connected to a positive tab, or all of the negative to a negative tab, right? Therefore, they are going to be considered again single cells. So this fold, for example, if you have 4D fold, means you have 4D single cell inside it. But in here, look at here, layers are individual. Layers doesn't have any connection as a single layer, but still they do have tab. For example, this one is the tab for a pouch type. It's positive tab, negative tab. Tap means, again, that tiny part of the battery that you are going to connect the ground or the positive source or the power source. So this is the structure of the battery. Cylindrical always is like folding the same layer. Cylindrical couldn't be individual layer. So in fact, I would say the structure of cylindrical batteries and prismatic batteries is very similar, because both of them are a very long sheet of cathode or anode or separator, but the way or the method of folding is different. Make sense? Make sense? What's the difference between their structure? So going back to the discussion in here, I was talking about polymer, lithium polymer. And I said lithium polymer is the pouch type, but like right now, you know, when I say pouch, means the layers are individual, but still all of them connected to a single tap as positive or negative. So there are some great advantages about the lithium polymer. In fact, in here, they are using lithium polymer technology for the positive. So this one is the positive of the battery, right? And they are going to have the dry solid for the negative. That's the structure of this type of the battery. So soft polymer for the positive, and they are gonna have like dry material, solid material for the negative. That's the structure. So in here, they are going to use also porous chemical or jelly-like electrolyte. So electrolyte, that's why I say solid state or jelly. Either of them. Jelly-like electrolyte for the for transferring the ion from the positive to negative during the charge process and reverse during the discharge process. So they have different shape. They can fit in most of the chassis, because still they are something that it can fit in any electric vehicle. Definitely, this could be a good choice for electric vehicle application. And of course, another advantage in here, they have a high life cycle. Means they are not going to get damaged easily. For a very long time, you can use them without any issue. But disadvantages is they have sensitivity to high temperature. Means they do have a range. If you are not maintaining this kind of battery in the range of 80 to 120, their chemical reaction will be a speed up, and as a result of that speed up chemical reaction, they are going to have high temperature, and high temperature means lack of safety, which is fire or explosion. That's the disadvantage for lithium polymer. So that's a little bit risky for electric vehicle application. I believe every now and then, nowadays less, but maybe years back, maybe 5-10 years ago, you were seeing in the news that maybe that electric vehicle experienced an explosion, even causing a little dangerous situation for the driver or maybe somebody else around. So one of the reasons for those kind of dangerous situation is high temperature. If the material of the battery is not able to tolerate high temperature, definitely explosion may happen as a result. One thing which is important for you to learn. Remember, I said most of the battery characteristics are given through the manufacturer, either as a data sheet, separate data sheet, or maybe as a label being stick to the battery. So look at here, for example, this is the battery type for lead acid. Lead acid like nominal voltage is 2.1. And of course, they do have like a specific energy, or they do have, for example, what is the major issue? Most of the manufacturer, even they give the range, the temperature range for the maintenance or for the like operation, under what temperature they can operate during the charge, under what temperature they can operate during the discharge. So you can compare them. For example, in this table, you can see lithium-ion has the highest nominal voltage, and that's why we say lithium-ion is the best choice for electric vehicles, since in electric vehicle application, battery is the only source, right? But for hybrid electric vehicle, we can use other sources as well. And of course, zinc A has the lowest nominal voltage, and that's the reason we do not use it for the electric vehicle application. Next in here, you can see another type, which is lead acid. Remember, lead acid is not a good choice for electric vehicle. Why is that? Simply because it takes a very long time for the lead acid to be charged. While when we are using any battery as a main source for the electric vehicle application, one of the most important factors should be able to tolerate fast charging. Since fast charging always means high temperature, we are speeding up the chemical reaction. Therefore, the battery or the material inside the battery must be able to tolerate high temperature without any safety concern. So I would say lead acid may not be the best choice for the electric vehicle application because we need to consider the heat generation and all of the damages. And your open circuit voltage in here, look at here, open circuit voltage in here is 12.6, means at 100% charge or a state of charge, you can see, and this is also another thing that manufacturer always provide. For example, for this battery, you can say at 100% state of charge, the open circuit voltage is 12.6. And of course, if it is 11.8, you may say, okay, I do have no charge. The battery is fully discharged. So here, battery is fully discharged. Here, battery is fully charged. That's what we call it open circuit voltage. One important thing in here, if you are gonna just have it at different, these are what we call it C rate. I introduced last session. For example, here at 60 amp, in order to understand what is the C rate, we have to understand what is the capacity of the battery. First, we need to know, for example, if a battery is 100 ampere, at 1 C rate, we have to apply 100. The capacity is what? And then in here, we have to apply 100 ampere. If we have, for example, at 2C, then it has to be 200 ampere. So, but if you want to say at 60 ampere, if the battery is, let's say, 100, we are going to have fully charged. And it takes, for example, at 60, it takes only 50 minutes, right? And so on. So this is how you can calculate. For the fast charging, means you are going to consider temperature. If you are not going to consider temperature, because when the resistance is increasing, what is the relationship? Relationship is V equal to IR. What will happen if the resistance is increasing? Can we keep the voltage constant? And then look at the current times resistance. If the resistance is increasing, means the temperature is increasing, right? And if the material cannot handle, means we are going to generate voltage more than the acceptable voltage. And if we are going to do that, definitely fire is happening. And that's why we need battery management system. If the temperature is increasing, temperature times current means voltage. Therefore, we have to have the BMS to disconnect the battery. Means the BMS supposed to have a voltage range. As soon as the voltage is start to increasing, it has to stop it. And we have to define what is the voltage. We have to say, okay, keep the charge. For example, keep the charge maybe up to 3.9. It depends. What is the characteristics of that certain battery? We can, for example, say during the charge, maximum V, if it is at around 3.9, then disconnect it. And V minimum, for example, if I'm at around 2.4, disconnect it. That's what the battery management system does in order to avoid any risky situation. Remember AGM batteries? AGM batteries, they do need different charger. What was the AGM battery? Their electrolyte was fiberglass. I introduced it last session. They do have a fiberglass electrolyte. For them, we do need a different charging system. That's why they are not really common for electric vehicle application, because people, they are not having access to every voltage source. Therefore, this is not a very common source of energy for the electric vehicle application. Another thing that I'm gonna introduce, and of course, these are going to have like 14 to 16 volts. So they have, these guys, they have like, if they are 14 to 16 volts, simply means they have less internal resistance. Less internal resistance means less risk, right? So you can charge them at higher rate, but still they need a special charging system. Another important thing that I'm gonna introduce for today is the charging stations. Which kind of charging stations we have? Any idea? Any idea about the charging? Is there anyone in the class who's driving an electric vehicle or a hybrid electric vehicle? Definitely you have to be familiar with the charging station. So which kind of charging station you are using for charging your electric or hybrid electric? Electric. Okay, which charging station?
I use level 2 or 3.
Level 2 or 3. If you say 3, simply means you are using DC charging, because in AC charging we have only 2 levels, right? So I'm going to introduce it. We have 2 types of charging system. We have AC charging system and we have DC charging system. There is a difference between them. AC charging system, it has only 2 levels of charging. Level 1, we use a normal, for level 1, we use a normal 120 volts, or let's say 120 volts on the wall. Therefore, if you are using level 1, it is easy for everybody to have such a charging system at home, and it's not going to cause you any extra cost. But the thing is, level 1 is going to give you only up to 16 ampere. So that's about that. So it is something that everybody can use such a system at home. But since it's not giving you high current rate or high C rate, therefore the charging is gonna take a lot of time, right? So what does it mean? Means, for example, if you wanted to full charge your vehicle, you may need to have it like 24 hours to be connected to the wall in order to drive. Maybe, I don't know, it depends, because vehicle and vehicle, it depends which type of vehicle. Some of them, you may be able still to drive up to 50, 60 kilometers. Some of them less, it depends which kind of vehicle you are driving. But we have in AC charging system, we have another level, which is giving you a little bit more. In there you had up to 16, but in here you can have up to 18 ampere. But the difference between these two are, kids, definitely everybody notice your system for the oven inside the kitchen. Your oven inside the kitchen is not connected to 120 volts. You know that or not? Of course, another appliance, your dryer inside your laundry is not connected to 120. For them, you do have 240. So that's another type. But in order to have such a system being, for example, installed inside your garage, still you have to pay extra money. Therefore, that's why they say level 2 is a bit costly than level 1, because you have to have that high power. You have to go through some specific wiring. And in addition to that, you need a special device like this level 2 plug-in. This is a plug-in hybrid electric vehicle charger level 2, but this is a plug-in hybrid electric vehicle charger level 1. This level 1, look at here, it can be connected to regular 120 volts, but this one is a high voltage. Therefore, you need something similar to what you have for your dryer inside the laundry or for oven inside the kitchen. That's why we say it's a little bit more costly. And it's not available everywhere. It's available only in some regions, right? But the advantage is it can give you up to 80 ampere. That's the advantage about this one. So I'm going to give you one example. For example, Mercedes B-Class 250E. If you are gonna charge it with level 1, that one I know for how long you can drive with it. So for that one, it takes almost 20 hours to be fully charged, and you can drive up to 87 miles with 120 volts after 20 hours of charge. Makes sense? So it takes almost a day to be fully charged and be able to only drive 87 miles. But if you take the same Mercedes, the same model, class 250E, and charge it with level 2, it takes only 3 hours. See how much difference in here? In here, it takes 20 hours in order to charge it and drive 87 miles. In here, it takes, if you use level 2, it takes only 3 hours to charge and drive 87 miles. So that's a huge difference. Make sense? So next, let's look at conversion of like between AC to DC. In addition to AC charging system, we have DC charging system as well. One of your friends just said he's using either level 2 or level 3. I said in AC charging system, we have only 2 levels, but in DC, we have 3 levels. We have level 1, which is going to be, and of course, always remember, charge is measured in kilowatts. Let me mention it somewhere. Charge is in the unit kilowatt. Okay, so when I say it takes, for example, in here, it takes like up to 14.4, means the charge in kilowatt is 14.4. Or in here, for example, if you are gonna just convert it, you can convert the ampere, right? So now, if you're having level 1, level 1 has a rate for the voltage, which is 200 to maximum. This is V mean, this is V max. 200 to 450 VDC. And you will have up to 80 ampere, and you can just have the charge up to 36 kilowatts. You will charge it up to 36 kilowatt by 80 ampere, and the voltage is something between 200 to 450. So that's for the level 1. So do you know for how long this is enough? Maybe something at around 3 miles. Or if you want it in kilometer, maybe 5 kilometers. After going through all of that, which is not really efficient, is it? It's not. But if you're looking at level 2 is still the voltage is same voltage rate of the voltage, but you are gonna have a little bit fast charging in here. It can handle fast charging simply since you have 200 ampere, means you are gonna like fast charge and you are gonna get up to 90 kilometers. Fast charging means less time. Make sense? Means, for example, in here during the 1 hour, you are going to charge at 80 ampere, and probably it takes like a lot of time. But in here, instead of 1 hour, you can just, for example, in 30 min charge it, because you can increase the current up to 200 ampere. Therefore, you are going to have fast charging in here, and you can just go up to maybe a store up to 90 kilowatt. But the good part in here is level 3. Level 3, look at the difference. Your maximum voltage could go up to 600. Definitely, you can in 50 minutes receive almost up to 80%, right? In 50 to 30 minutes. It depends for which vehicle. 15 to 30 minutes, you can charge your battery up to 80%, which is great, right? And you are going to have it almost for 20 miles, right? So it's going to be a great one. So, but the thing is, level 3 charger also has a little bit of maybe benefit over the other one, which is time, and you can get more charge during this shorter time, but still it's not available everywhere. It might be a little bit difficult, but definitely level 2 is more available. And of course, another thing is level 3 is not usable for every type of vehicle. Not every vehicle is something that you can use level 3 for. Not all of them are handling level 3 yet, maybe at some point. Whatever we have, not all of them are compatible with level 3 charging. So just few residential locations may have level 3 charging, not all of them. And the reason behind it is the type of the station and the charging is not compatible with all vehicles. So I'm gonna stop it right in here. And in the next session, I'm gonna give you a summary what would be the topic. I'll be starting to teach you how to design battery. I'm gonna start from the basic part, such as, for example, the connection between the batteries, which is series and parallel. And after that, I'm gonna come up with some problems on how to calculate how many battery cells or how many battery modules you need in order to create a battery pack. Because whenever you are going to connect the batteries together, either in series connection or parallel connection, the plan is creating a battery pack for electric vehicle application. So you have to be able to first calculate the number of the cells, and right after that, the method of connection between the cells in order to get the capacity that you are looking for that certain application. So I'm going to stop it right in here. Anyone who has any question, feel free to ask your questions.